This is the summary created from the video. Lecture 22 Demonstration IX. Interfaces in Java follow specific properties, and if these properties are not satisfied, interface creation may fail. We will explore this concept. An interface cannot be instantiated directly, but its object can be declared. However, attempting to create an object of an interface type leads to a compilation error. Nevertheless, declaring an object of an interface type without instantiation is allowed, and even an array of interface objects can be declared, although not instantiated. To implement an interface, all its methods must be correctly implemented. Here, interface I1 plays a public static final field PI, a lambda field, and an abstract void method I2. Class A1 implements I1, overriding the method I2, and can access the PI constant from the interface within its own methods. The main class creates an instance of A1 and invokes its methods, including the overridden I2 method, demonstrating successful interface implementation. However, declaring an uninitialized instance variable X in an interface leads to a compilation error, as interfaces cannot implement other interfaces or abstract classes. Only classes can implement interfaces. This example illustrates errors caused by improper use of modifiers in interface methods. It demonstrates an interface with an invalid final static method declaration, which causes a compilation error. Removing the final and static modifiers from the interface method resolves this issue. Additionally, implementing an interface method without the public modifier also results in an error. Successful compilation occurs after addressing these modifier and class file name issues. In this illustration, we see single inheritance with an interface I1 that contains a variable X and method 1. I2 extends I1, inheriting sex and having its own members Y and method 2, which is abstract. Class A1 implements I2, inheriting methods from I1 via I2, and declaring its own variable. The main program creates an A1 object, calls methods 1 and 2, and accesses the interface variables X and I, demonstrating successful execution and single inheritance with interfaces and implementation. Class A implements multiple interfaces like I1 and I2, gaining access to methods from both. Interfaces can have static variables, like J and I2, which are accessible to implementing classes. Class A implements both I1 and I2, demonstrating multiple inheritance in Java. Class B extends A and implements I inheriting from A, and requiring the implementation of as methods. B's constructor calls super for A, implements as print method, and has its own additional methods. Interfaces allow a class to inherit from a superclass and simultaneously implement multiple interfaces. This facilitates the sharing of static variables across packages and classes as shared constants. Interface variables are accessible to the implementing class without explicit declaration within the class. In this example, a class uses the interface's shared constants in a probabilistic method to generate random output. Multiple runs of the program using these shared constants generate different random outputs each time. The geoanalyzer interface defines area and perimeter methods, which are implemented differently by classes like circle, ellipse, and rectangle. Geoanalyzer has a static variable pi and abstract methods area and perimeter. These classes implement geoanalyzer, providing their own logic for the area and perimeter methods. The main class creates objects for circle, ellipse, and rectangle and calls their respective area and perimeter methods. Notably, a geoanalyzer interface object can refer to any implementing class, enabling polymorphic calls. Abstract classes and interfaces both enable polymorphism, but with differences in implementation details. An abstract class can have method implementations, while interfaces only declare method signatures. Subclasses extend abstract classes, but implement interfaces with single V's multiple inheritance, respectively. The demo illustrates polymorphism via abstract methods, overridden in concrete subclasses like circle and rectangle. Java supports both abstract classes and interfaces, offering trade-offs in flexibility and inheritance rules. This demonstration highlights the key difference between abstract classes and interfaces. While the concepts of abstract classes and interfaces are similar in many ways, interfaces can only declare method signatures, whereas abstract classes can provide method implementations. Any doubts regarding interfaces can be clarified through queries. The programs used in these demonstrations are freely available for practice and to solidify the understanding of abstract classes and interfaces. To summarize, interfaces enable multiple inheritance and dynamic binding in Java. Interface members are implicitly public, static, and final. Interface objects can be declared but not instantiated directly. Interfaces facilitate sharing of constants across classes and enable polymorphism, along with abstract classes. Classes can implement multiple interfaces simultaneously. While interfaces only declare method signatures, abstract classes can include method implementations. Mastering interfaces and abstract classes is crucial for leveraging polymorphism and inheritance in Java. Please stay tuned for more summary videos.